But today, we're here. So that's my sort of day job is sort of as a cloud solution architect. I work in the digital and app innovation team. So I work with companies, customers, people that are interested in building stuff on our cloud and modernizing, doing innovative stuff. I've been interested in green software for maybe a year and a half or so. So I've been thinking about that and kind of joined a few communities and building upon that, which is why I'm kind of interested and excited to chat with you about it and get your views and thoughts and opinions, because it is pretty new. Sustainability is kind of the forefront of kind of a lot of people's minds at the moment. But focusing in, as a software developer, as the solution architect, focusing in on what control do you have on sustainability? So thinking about green software and is pretty new. And you'll probably figure that out if you've not already figured it out as we go through this. So I'd love it to be interactive. Shout your thoughts out, your comments out, your questions as we go in and along. That would be really, really good. Sound all right? Cool. So I know you've seen these statistics before, I'm sure, but I thought framing kind of where we are and perhaps where we're going was a good starting point to, I guess, think about why this is important. And the second bullet there, 20% of the global electricity consumed by 2025, 2 years' time, will be consumed by data centers. The world in which we live, as developers, as architects, so we have that kind of ability to do something about that, to make it right, to do the right thing. Just astonishing numbers. Some of the other stuff, probably worth just highlighting. We know that, and this is sort of a typical cloud conversation, we know that servers in private data centers, for a whole bunch of reasons, are nowhere near used at capacity. We'll touch on this later on, but those servers are switched on, right? But they're not at capacity. Containers, they've helped 60% improvement in density, which means, of course, we can put more workloads, more resources on those servers that are sat there perhaps under capacity, which has helped, but it's still not really solved the problem. And of course, as I said, those servers have to be switched on, whether they're doing something or not. And it's an obvious thing to say, but when you actually think about it, they need to be powered up for when you send that request or call that API, they need to respond. So that's sort of the world we live in. And the conversation I wanted to have today really was thinking, beyond the quick win. So kind of in my world, a lot of the time you hear people say, move to the cloud. That will make you more sustainable. And that's likely correct. Likely. You can see the number there. It's likely to be a 93% improvement in your energy usage and therefore your carbon efficiency than doing something on-prem. But that's kind of like quite a big granular thing to do. Just move to the cloud and forget about it and walk away, given the numbers on that previous slide around what the consumption of electricity in data centers is going to be. Another one, use serverless. Don't put a virtual machine that's sat running. Use serverless, and then your code will only execute whenever it needs to. It's still a good thing to do, but we're going to talk a little bit more granular than just using serverless. Okay. Make sense? So I thought I'd start with some definitions. I'm interested in your views on here. What's happening is we're using terms all the time, and we use them in conversations sometimes quite flippantly. And again, as you'll see as we go through some other definitions later on, particularly around climate commitments, they're starting to have precise definitions now and mean specific things. So you've heard me talk about carbon already quite a lot. And we talk about carbon, it's the moniker we used for global greenhouse gas emissions. It's kind of And it's really what we're talking about is a carbon equivalent, and the notation, if you see it formally written down, is the CO2 EQ. So whether we're talking about methane or carbon, whatever the greenhouse gas is, for simplicity of language and I guess sort of understanding, we talk about carbon equivalents. So if a methane emission is, for example, 80 tons, but actually the equivalent carbon emission of that from in terms of environmental impact is 1 ton, we convert that to a carbon so we can kind of have a common kind of platform. Does that make sense? Yeah, I'm not sure I described that very well. We measure carbon in grams of carbon per kilowatt hour. So you'll see that later on when we start to look at kind of energy consumed and carbon emitted. But so it's the grams of carbon per kilowatt hour when we're talking about carbon emissions. Make sense? Yeah? Cool. So energy sources, we'll be talking about energy sources as well, and there are some terms around there, and these can be used collectively as well, or we can combine them together. So, of course, they're low carbon energy sources on the slide, but the opposite of that is a dirty energy source, and the one that we all know is coal. So burning coal is a dirty energy source. The clean, or the low carbon energy sources. So we have clean energy, and that's essentially, when we use the term clean energy, we're saying it's an energy source that does not emit carbon. It's clean. Green energy, clearly sources from nature. So an example of clean energy might be nuclear that isn't green energy. Isn't green energy, such as wind or solar, something like that. And of course, a renewable energy is an energy source that is renewable, such as wind and solar. I was chatting just before we started about proxies and stuff, because what you'll find is the journey of green software is pretty new, as I mentioned already. And if we want to start to think about it and do something about it, one of the easiest ways to do that with what we currently have is to use a proxy. And you'll see that cropping up quite a bit. And the proxy that we use most of all is cost. And what we're really saying is that if we measure the cost of something and we reduce the cost of something, i.e. it's fair to say if we're reducing the cost, we're probably reducing the resources that we're using because it's costing us less. If we're reducing the resources that we're using, it's reasonable to infer we're therefore emitting less carbon. So we're not always measuring the actual emitted carbon, but we're kind of using a relative measure to say, do you know what, we've improved our sustainability of software because we've reduced the cost, therefore we have emitted less carbon. Make sense? I'm going off at a tangent slightly here, but I also think cost is another interesting proxy, or it's an interesting analogy. Because I was involved, as I said earlier on in the introduction, I was involved in the early days of Azure. And it was not uncommon for us to have conversations with customers and say, move your workload to the cloud, it'll save you money. And it was a fair thing to say, because the likelihood is it would have been cheaper and therefore would have saved them money. The reality at the time was no one really had an idea. You couldn't put a number on it. You know, this is 12 odd years ago now. So you'd walk up to a customer and you'd say, kind of, all right, is it going to be cheaper? Yes, it's going to. How much does that software cost you at the moment on premises to run? They had no idea. Obviously, power, cooling, hosting, as in the on premises. They might have known what the licensing costs. They might have known what the development of writing the code was, but they didn't have an idea of costs. Where are we today? They precisely know the cost of the line change in a bit of code because they have the information in front of them on a dashboard. In fact, we go one step further in Azure and in other platforms as well. We have this thing, Azure Advisor, that tells them they can reduce their costs if they right-size stuff or switch stuff off. So I think that analogy went off on a tangent slightly, forgive me, but I think that analogy there is very similar to where we are with green software today, that we don't have that, what's that bit of on-premises software, what's the carbon emissions of that? No idea. Will it improve if you go to the cloud? Highly likely. Can we measure it today accurately? No, we can't. So I think it's a really good analogy of where we are. Another one is performance, which is very, very similar to cost. Make sense? Cool. So I said there, oops, I need to move that over, forgive me. Need to get my mouse as well. It is that way, cool. So I said it's pretty new, it is pretty new, but one green software, so that specific bit around building stuff. There's the Green Software Foundation. If you're interested in this, highly recommend you kind of go visit this site. I'm a member of Green Software Foundation now. They're doing interesting stuff with software around kind of resources to learn about it, tooling that we'll get onto a little bit, and guidance around best practices and stuff. So, a lot of the forefront thinking is from this company. There's a whole bunch of bigger companies that are behind this that sponsor GSF. It's an independent org. So one of the things that they did was come up with 8 principles of green software engineering. Now, these are V1, and so therefore they're no longer really the principles. There's a V2, which we'll look at next, but I've renamed these principles to definitions. Maybe I should have renamed them to concepts, because there's something that I just wanted to talk through with you and get your views on and see if you've thought about these things before. And then when we look at the new principles that have come out of GSF, you'll understand them. They'll make more sense. Okay, so the first one is, and you'll also realize why there's a V2 when we go through these, because some of these are sort of obvious, but perhaps needed saying a year and a half, 2 years ago. The first one's carbon efficiency. And that is essentially saying you need to be more carbon efficient. You need to emit less carbon for the bit of work that you're doing. It's a pretty obvious principle given what we're talking about. The next one is energy efficiency. What this is saying is something very similar. Per unit of energy, you need to do the most amount of work you can. So that machine's switched on. You need to do the most amount of work you can in order to be sustainable and emit less carbon. Now it starts to become a bit more interesting. Carbon intensity. Anybody heard of carbon intensity before? Cool. A few people. Brilliant. So carbon intensity is the amount of carbon emissions at any given time in any given geography. Okay? Have you guys come across electricity map and what time? Yeah? Cool. So I'm quite visual, so I like stuff like this. So this is electricity maps. Landing page here. Electricitymaps.com, go to app, and it will spin up this app, and it will give you a visual representation of carbon emissions, CO2, so grams of carbon per kilowatt hour. So if we go look at the UK at the moment, we can see we're 106 grams of carbon per kilowatt hour. We go to look at Scandinavians, 16 grams becomes kind of interesting when we start to explore. Poland, 901 grams. So really what this is saying is at any given time, the carbon intensity can change. And it can change because of the demand on that particular region versus the supply to that particular region. So if the supply is clean energy and it's meeting the demand, then clearly your carbon intensity is going to be quite low. But as that demand increases, the call for energy also increases. It's more likely that increase in energy comes from dirty energy than clean energy for a whole bunch of reasons at the moment. It's difficult to capture clean energy if it's not used. And so dirty energy is kind of easier to manage the peaks. And so that demand increases, the carbon intensity increases because the energy source that meets that increase is a different energy source. Make sense? Let me show you one other one actually, because we'll talk about it earlier. Talk about it later on. These are the most common ones. Electricity map is a common one. It also has an API. The other common one that you'll come across quite a bit is something called watt time, and again that has an API. So you can register for these sites, and you can then start to consume their APIs. They're RESTful APIs with Swagger descriptions. Okay, so we've done carbon intensity. Embodied carbon. Embodied carbon is the amount of carbon emitted during the entire production life cycle of a bit of hardware, such as a mobile phone, such as a laptop, such as a server, whatever it happens to be. And this is particularly the industry that I work in, and I guess most, if not all of you work in. This is sort of interesting because historically we've worked in an industry that has wanted to push the bounds of user experience and all of these things. And what we're saying now is, what we really need to do is prolong the life of devices, because those devices cost carbon to produce. And therefore we shouldn't really be forcing anyone to throw an old device away and buy a new one because of the embodied carbon of that device. Energy proportionality it's linked with energy efficiency. So the energy efficiency is, be efficient with energy usage, do the most amount of work. Energy proportionality is saying that machine switched on, that server switched on, do the most amount of work with that entire server as you can. Okay?
How does that relate to the energy efficiency?
Energy efficiency, and this is why the principles have changed a little bit to be a V2. So the energy efficiency is just sort of making the statement that is per unit of energy, you need to be efficient with your bit of code. Energy proportionality is sort of looking at it a little bit broader and saying, do you know what, that server's switched on. All of that, and you think about containers and density and putting more stuff on that server to achieve more workloads for the energy consumed in the idle state of that server. Does that make sense?
I think the way I look at it as well is that when a server's powered on, there's a certain base level of load that it's drawing for spinning disks, having RAM, this, that, and the other. And so let's say that's 30-40% of the power draw. And then the workload on top only adds like, say, an incremental 5% per load. So energy efficiency would be the per workload addition, whereas energy proportionality would be the amount you're kind of sweating it. Right? So if you've got, running 80% load on something all the time, you're actually kind of running, I don't know, whatever the maths was there, 40% of the base, 40% of the load, you're kind of using more for the workload that you're running rather than the base.
And it's hard to read into that, because the underlying message is it's better to have one machine at 100% than two machines at 50%.
Yep. And again, cost is a really good proxy. I remember in the early days of the cloud working with a customer who was determined, and they actually achieved it, a company called Riskmetric, who did financial calculations. They were running their VMs at 98% CPU utilization because they were paying for it. And it was a cost driver rather than a sustainability driver then. But it was like, if we're paying for that machine, we really want to get the most out of it. So it's very similar And that's why we use cost as a proxy quite a lot of the time.
Would the machine not degrade quicker if it's close to being maxed out all the time, and then you have to replace?
Well, I was thinking you'll actually get less efficient. Some depends how the software is written. It can be less efficient. It's right at the limit of its performance, and things start queuing up, and then you get a degradation, and then you have to start another machine up to take the load.
Yeah.
So sometimes it's better to be at 80% or 60% or something.
Presumably you factor that into the maximum you can get out of the box, though.
Yeah.
But 100% means the CPU is 100% utilised, and presumably some of the other resources as well. And that's not always the most efficient way
Yeah.
to run a machine.
No, I agree. It is getting
It's a bit quite complicated.
Yeah,
Isn't it, working on
These are quite, and these are V1, right? These. The way that I kind of approached these in the early days was I learned a lot from these because I was dead new to it and just sort of just thinking about them in kind of that way. And there is no go do this, go press this button. Networking, you'll all go, oh yes, on networking, because it's sort of, yeah. If you remember service-oriented architectures, web services, all of the guidance that we gave around, we all knew about networking, be aware of the network utilization, the payload sizes, the chattiness of the interfaces. This is just saying be aware of that, right? Be aware of the length of the network, the switches on the network. If you can make one call and get all the information you need, and it's all the information as opposed to bulky information, do that. That's what that's saying. So demand shaping goes back to carbon intensity, that you've already probably figured this one out anyway. So demand shaping is basically saying you're running your code at 7 o'clock on a Tuesday in the UK. The carbon intensity of the location that you're running it in is 300 grams of carbon per kilowatt hour. Do you need to run that software now in that location? The answer might be yes. The answer might be no. You might be able to postpone it 2 hours where the carbon intensity is reduced from 300 to 50 and you can go run it then. You might be able to go move it to a different geography. Scandinavia, go run it there, 19 grams of carbon per kilowatt hour. It's basically, and this is, for me, this is one of the ultimate kind of goals here, is making our applications carbon aware. When those applications are running, thinking about that business decision, because sometimes that application does need to run in a particular location, geography, at a particular time. But sometimes it doesn't. Sometimes we can just wait a little bit. And then to your point, the optimization, you can't just do one thing. This is quite complicated and there are lots of moving parts, and therefore we need to start to think about these things more sort of together. Make sense? So they were V1. These are V2. These are on the Green Software Foundation website. They'll look very familiar. They're in those three buckets: the carbon efficiency, hardware efficiency, and kind of carbon awareness that we've talked about. So all of those things we understand. On the right-hand side, there's just two new ones. There's measurement and there's climate commitments. And the notion, behind measurement is how can you control something if you can't measure it? So let's have a look at measurement. I'm guessing this is not a surprise to you. The most common and well-known way of measuring emissions today is the greenhouse gas protocol. And that talks in those different scopes, scope 1, scope 2, and scope 3. And lots of companies report on these different scopes of their carbon emissions. As you can see, real high level, I've got a picture of this that we'll flip onto that, but scope 1, direct emissions. These are, within your company, within your control, the emissions that you make. Scope 2 are purchased, they're indirect emissions, but such as purchasing energy. So the emissions when purchasing energy is a scope 2 emission. And then scope 3, also indirect, is other activities that you're part of in your business. And the obvious example that we always sort of talk about there is the supply chain. The picture that I've got, I think it's still up, is It's an Azure example. If I can find my mouse. So for those of you who use Azure, if you use other clouds, they have theirs as well. We go and you can go install an app for Power BI. For Azure, there's also one for 365. What this does is this will give you your scope 1, 2, and 3 emissions from using the cloud, from running your workloads in the cloud. Any guesses how it does that? So it uses a proxy, and it uses the billing API as a proxy. So it's using billing, again, cost which is a reasonable thing to do because we sort of know how much you're using of a certain resource and therefore what those emissions will be. Yes?
Does it take into account like price fluctuations of things? I don't know. I'm just thinking like there's a chip shortage, wasn't there?
Yep.
Push the prices of chips up, so that might have like a knock-on effect to the server market, which would have a knock-on effect to cloud prices potentially or something. So that would push the price up, but you're not using more carbon, you just the resources become more expensive.
100%. There are definitely situations like, you know, a more powerful machine. You're paying for a more powerful machine that costs you more money. You're working quicker, and it might not be the same. So the answer is yes. The answer is no. It doesn't take into those things into account. The answer is that it isn't a perfect proxy, but it is. It's kind of good enough for where we are at this moment. This is my interpretation. It's good enough for where we are because we can see changes and we can measure impact from doing it.
Because the purpose of it is optimization rather than an absolute value.
Yes. Yes.
You can tell relatively you've made an improvement.
Yeah.
Even if the box is imperfect.
Yeah. And even when we go back to these things, right? This one. This is information from the grid. So this might not be a true reflection of the carbon emissions within the data center that you're particularly using, or your house that's got solar panels on the roof and all of those things, right? It's again, it's the best we have at this moment in time. So it's useful, where we are on the journey in understanding this, but it's not a true number that we can be really confident about.
Just one quick note. The piece of work that I'm doing is a low carbon scheduler for Kubernetes. And it doesn't use this one, but it uses the National Grid carbon grid intensity map, which is kind of regional. So if you're, like say the data centre in London is a different carbon grid intensity at Manchester, and when you schedule the workload, it kind of calls the API and kind of says where to run it, basically based on the, on the live demand, and the forecast goes 96 hours out, so you can kind of set almost a carbon budget. Sort of say only run when it's like less than 200 grams, and then it can just pop it anywhere where it's less than 200. It's quite nice.
Very similar to what Fuelers are doing here as well.
Yeah, good.
As a fan base, you got to figure out when to go.
Very, very similar.
Does the calculator then take into account any, or does it use any of the APIs for carbon intensity?
Not today.
Okay.
No. We'll get onto that in a bit because the Green Software Foundation are doing something that does, but this emissions dashboard doesn't. It just simply uses the billing API as a proxy in order to generate, and it talks about the calculation. This was the picture that I wanted to show you. It's quite a nice picture of all the different scopes. The scope 1 is what you produce, and scope 2 when you're buying stuff, and then scope 3 part of the supply chain and stuff. But it goes into the calculation of how it does it through the billing API, which is quite a common approach. Okay, so it's sort of clear that this is kind of useful, particularly at a kind of a company level, and lots of companies talk about their Scope 1, Scope 2, Scope 3 emissions, and a lot of them have to report that to the board, and they're measured on it and stuff. And so it's all useful, and it's driving, of course, behaviour in the right direction. But if we start to think about green software, then this is sort of too granular, too large a granulation for us. We need something a little bit more precise. And this has come out of the Green Software Foundation. It's now being submitted to a body. It stands for Software Carbon Intensity. I had to think then, because it's just not an obvious set of letters to me. I don't know why when we're talking about carbon intensity and software, but it just isn't. We've talked about all these things already, so it might look a bit weird, but you already know what all of these letters mean, but we'll go through them. So E is the energy consumed per kilowatt hour. And what we're finding is that a lot of suppliers and manufacturers are giving you those numbers now. So you can measure it yourself. So Microsoft does a global hack each year in the summer. I kind of did a green software. There's a bunch of us, 4 or 5 of us, that got together to play around really with this formula. And Intel have a really nice profiling bit of software. My machine's running Intel. So you can accurately measure the energy usage of your particular machine given a particular workload per workload in this profiler. It's really, really nice. So I was basically playing around with coding techniques and the impact on carbon emissions, and do different coding techniques to achieve the same thing, impact emission. The answer is yes, it does, which I guess isn't a surprise, but anyway. So energy is the E, and manufacturers are providing what the energy are. That's particularly relevant to the cloud, right? So if you're wanting to use this because you're running software in the cloud and you're running on a particular virtual machine or service or whatever, you need to know what the energy number is. And so we're providing that information, and most people are providing that information. I is, sort of back to your question, I is carbon intensity. So I is the carbon intensity of your software running at this particular moment in time. So that needs to go call those APIs to find out what it is. You multiply those together, and then you add the embodied carbon. So that was the carbon emitted during the production of the server that perhaps you're running on, or the laptop that you're running on. And then that calculation is per whatever the functional unit is. So per API call, or per, I think this example here, per user, per device, whatever it happens to be. So that's the calculation that gives you the carbon intensity of your software running at this particular moment in time. You have to do it manually today, each time, which is a bit of a downer, but that's where we are. But there's agreement on that formula now. Make sense?
Sorry.
Yes, right.
If you're moving on, wasn't sure where you're going. It's like this one here. I guess what's troubled me mostly about this formula is how you use it in practice.
Yes.
So absolutely for a single server, something run in the cloud, but when we're writing software, it's not only deployed somewhere, it's used somewhere. We have clients, we have networks, we have all of that.
Yes.
And actually trying to calculate the carbon intensive piece of software. Yes, the formula holds. You can do that for a mobile phone. You can do it for the 1,000 varieties of mobile phone that the software is currently being viewed on. But it's impractical, right?
Yep.
Have you come across anything in the space that you'd say can make it more practical to use this formula? So
no, but I fed precisely that back to the working group that's come up with this formula for the Global Software Foundation. So the Green Software Foundation. So I completely agree. And the way that I think about that is, and tell me if I'm thinking the same things as you, I think about that design time versus runtime. I think about when I'm designing something, I'm doing it on my machine, maybe I'm doing it at home. If I want to measure the impact of any coding techniques that I'm using or any architecture that I've made, that's kind of a design time consideration that I need to measure in order to see the impact. The runtime, which is this formula here, is actually a completely different thing, because it's running in UK South as your data center, and I can precisely figure out what the number is, but that doesn't necessarily help me when I'm in design time mode. Is that what you meant?
Potentially. I think my worry is that that maybe this would lead to an element of greenwashing, if you like, where you design your software so that it has minimal impact in the cloud.
Yep.
It's got really good efficiency there because it's offloading
All
loads
right.
of its
Yeah.
compute to
Yep.
client devices, which are horribly inefficient. But we're not measuring that, so it's fine.
Yeah.
It's,
Yeah. No, it's a fair comment. Yeah. Now this formula is used for the particular runtime host it's on, and if you move that runtime host, then you need to go apply that formula in other places. I think we were saying slightly. What was in my head was sort of slightly different from. I think there's a design time and a runtime, which would pick up on what you're doing. I think because I'm saying that I really want to know the design time implications of what I'm doing because I don't know where it's going to run.
and the R, right? If R is user,
Yeah.
then every user's impact is actually that's another device, right?
Yes.
Another set of impact.
Correct. Yes.
And everything else.
Yes. Yeah.
Do you think there's any effort, or have you seen any efforts by, when we say client devices, I mean, very frequently we're talking about browsers now.
Yeah.
And so that is a sort of a bottleneck and a large kind of intervention points that you could use to try and do some client-side optimization as well. So have you seen any effort from the likes of Microsoft, Google, Mozilla to try to manage the carbon intensity of the software that servers are asking their clients to run?
Yes. Yes, there's lots of internal stuff that's happening. There are other areas that are very similar to that as well. That they're working through it's research at the moment. They're working through. I guess to your point about being accurate with the information and the guidance. So it has to hold up, right? It has to be true. So whether gaming is another area, right? When you kind of think about what's happening in gaming, what you offload, what you don't offload, is it a fair assumption to say if you do this, it's so lots of sort of people are thinking about that and figuring out what the most appropriate kind of architecture and offload is. The other comment I'd add, and we can have a look through because we'll talk about them towards the end, is there are a lot of patterns that are on the Green Software Foundation, not that you've come across them or not, but lots of recommendations on architectures and approaches on that. So some of that handle kind of that notion as well.
Just to add, there's a plugin, I think, for Chrome that kind of gives you a carbon impact of your browser.
Yeah.
And I think all that feeds back in to some system. Like kind of, if you're watching a video, obviously that's using more network bandwidth, so the impact of that. And it kind of gives quite a nice breakdown of like the carbon, your personal carbon profile. But I think the metrics all go back and kind of try and build a better picture. Obviously it's imperfect, you don't really know what accuracy they are, but it's sort of in that direction, I think.
You could see someone who owned a whole vertical ecosystem, such as Google, where they own the browser and they own YouTube, and people use it to stream and they've got the access to the plugin data, would maybe be using that to optimize how YouTube does its streaming. So.
Okay. So the other new commitment, so that was the measuring, which was a new commitment on the V2 principles. The other one was climate commitment. And I kind of alluded to some of the reasons at the beginning why kind of this is important now, that the terminology that we use is becoming more precise and perhaps more important. So you'll have definitely heard of some of these words that perhaps are used interchangeably. We all do it, but actually they have precise definitions now as well. So on the left-hand side, and this is all about, okay, what's your strategy for reducing carbon? What is your strategy for that commitment? Essentially, there are two approaches. One is offset and one is elimination. Elimination is sometimes called abatement if you've heard that word used. So here's a quiz, and I would absolutely not get this answer right, by the way. So during the pandemic, all that fun time we had working from home, not going on holiday, essentially not doing anything. Have a guess in percentage terms what the reduction in carbon emissions were during the pandemic when we didn't do anything.
30%?
On a scale like worldwide or?
Yeah.
I think it was very high. There was a huge reduction in the visible emissions as per some NASA studies, particularly in less carbon emission countries like China. So maybe even higher than that, maybe like 50 years. But I saw on the diagrams of like carbon output from China, it was like it had gone from a sky of black to no coverage whatsoever.
I'm going to say it's a rounding error. I'm going to say it's 1% lower.
There was a period when nobody was driving.
I'm going to say the industrial activity, the power generation activity, all of the rest of it, the shipping, all that stuff. I think that was 99% of it. I think we discovered during the pandemic that if we stop all kind of human leisure activity and individual stuff, it doesn't even make it scratch.
Yeah, industry is by far the biggest concern.
Yeah.
Taking away individuals' cars is a tiny drop in the ocean compared to ships and trains. Ooh.
So the number I saw, go on.
I was going to say it was really hard just because of the data, but you might have a really good point.
I've got a shame I ought to have swag, didn't I really? Go on, you want to say something? No. So the number I saw was 7%. 7%. Which illustrates really well, I think, how really, really, really difficult it is to eliminate. And it's reasonably accepted that we probably can't eliminate. We have to think of other strategies to improve the situation, particularly when we look at the Paris Agreement of 1.5. So, offset and elimination. Offset breaks down into two areas. One is avoidance, and the other one is removal or neutralization, but removal. If you take those definitions and then apply them to the terms that I know you've heard on the right-hand side, you can see that they have precise meanings. So when someone claims to be carbon neutral, what they're saying is that 100% of their carbon emissions are offsetted. And that can either be through compensation or neutralization, it doesn't matter which. But you're carbon neutral if you offset 100% of your carbon emissions. Net zero is a little bit more complex, I guess, than what you think it might be. It basically means 90% of your emissions are eliminated. You do not emit carbon. 90%, which is really, really, really difficult to do. And the remaining 10%, because we kind of all agree that you can't get rid of 100%, you're going to emit some carbon. The remaining 10%, in order to work towards that Paris Agreement again, has to be neutralised.
Do they have to be 90-10? Can they be 80-20?
They have to be 90-10 for the definition. Yeah.
Is that by definition 90% or 10% of what they are at a moment in time now? Because you could just go really mental for a bit.
Yeah.
And then
like those sales.
Classic Simpsons saving money, where Bart says, "I'll give up smoke, I'll start smoking and give up." He says, "Well done."
On that definition, if you're net zero today, you can't really be net zero tomorrow, right? Unless you eliminate 90% of what you did yesterday. If you're taking one as your discrete.
Yeah.
What a catch-22.
Yeah. So does this have like a date associated with it? So saying going from 90.
Yeah, what's the reference?
It's well, I don't. It doesn't have a date associated with it that I've seen. It's all your emissions, yeah, at any given time.
If you started something new and it was naturally green, then you're not net
You're
zero
not net
because
zero.
you're 100.
Yeah.
You're still doing
Yeah.
So 100 is just a small pie, right?
Yeah.
You're still small 100.
Yeah, but there's a certain amount of energy usage, I suppose, of which 90. Yeah, you eliminate
It's
it.
depends where you start.
Yes. I think people are free to define.
Zero divided by zero. I think people are free to define it as matching.
What does it mean by neutralised?
Is it a government?
Is that like sort of planting trees?
Correct, or carbon capture schemes or something along those lines, yeah.
Okay.
Bit like,
Yeah.
bit like the
Yeah.
net zero World Cup.
The moral of the story is that these have precise definitions that if you're working towards, or your company's working towards a particular strategy, then kind of understanding what that means is kind of important to understand how you're going to get there.
I think they mean 90% current
Yes,
emissions
yeah,
are
yeah,
in
yeah. Yeah.
Relative to what's
Cool.
at this moment.
Typically, people who sign it, like excavating the global reporting, there's all sorts of complexity and kind of measured at every stage.
There's definitely loopholes, aren't there?
There's loopholes, and also the problem partly is measurement as well. Like
Yeah.
How, like how you can measure things changes year to year. So in a way, it's aspirational, right? But
Yes,
it's,
yeah.
It is,
Yeah.
It's year on year.
Yeah.
I'd always hoped net zero meant compared to what you'd ever produced as a company. So you'd now dated your emissions and you've neutralised all that you've produced in the past.
That's unfair.
That feels like what net should be.
Yeah.
Unfair on a new company that started from a lot more.
Yeah, yeah.
Okay, two other things I wanted to make you aware of. We've sort of touched on them already, but these are projects, again, in the Green Software Foundation. One is a Carbon SDK, which we kind of sort of touched on earlier on. It's available. It was released, I think, last month, last month, I think. You can go download it and play around with it. It does use, it's independent of the source of carbon intensity, but today it uses watt time and it uses electricity map. You need to register for those APIs, and then you can essentially embed that in your software and have a play around with it, and look at making your software carbon aware. And the other one is around the guidance that Green Software Foundation is doing, and there are quite a lot of patterns at the moment. Go hit those. These are all from the Green Software Foundation site that we looked at earlier on. So patterns.greensoftware.foundation. Get my mouse. Here's a catalogue. It splits them into kind of, I guess, obvious buckets around AI, cloud, and web. And then there are a whole bunch of patterns that different levels of granularity in your architectural software that have been through the review to say they're worth publishing in the catalogue. Okay, so where are we? So this bottom sentence for me kind of maybe should be the only words on this slide. Thinking about sustainability and improving it is of itself perhaps enough to justify actually doing it, thinking about it. But the reality, and we've discussed a lot of these already, but the reality is that there are other advantages when you start to do stuff like this, which are kind of interesting. First and foremost, it's cost. It's like being carbon efficient. We've talked a lot about using cost as a proxy. Well, guess what? If you start to think about carbon efficiency, you are likely to reduce costs. And therefore, that's quite a good thing to be able to do as a byproduct of being more sustainable. And because perhaps you're thinking about the architecture in a different way, you're thinking about the code in a different way, you're kind of instilling good practices in your development teams, that they're thinking about the impact of their code more. And again, that's very, very analogous, I think, in cost. 15 years ago, how many developers were thinking about the impact of cost of their code? Whereas now, kind of most developers, particularly in the cloud, are thinking about cost when they're writing code because they can see what the cost is. We talked about demand shaping around, carbon intensity. That can give you, better forecasting of what you want to do, when you want to do it, perhaps from a business point of view, but also from a technical point of view. If you reduce emissions, then you don't have to think about offsets, you don't have to, buy carbon tokens and stuff like that. And you're also increasing the life cycle and usefulness of hardware, servers, devices, stuff like that. And that was it, although we've got a few minutes left, so I can go through some quick wins, or we can just sort of do some Q&A and comments and thoughts and stuff. It's up to you guys.
Quick wins.
Quick wins. I've left them after this slide because they're tenuous links to green software. They're definitely around green software. It's what I'm part of a working group at Microsoft, and there was an initiative around quick wins on cost optimizations for stuff, and they wanted one on green software. So we came up with these quick wins that hopefully are useful, but they're not all 100% directly just on green software because of where we are with thinking about green software. So Green Software Foundation has a learning path. They didn't when I put this slide together, so I should have put that one on there as well. But we have a nice MS learning path on Green Software Foundation that we sort of recommend going through. Covers a lot of what we've been talking about, so perhaps you guys don't really need to do it anymore, but it gives you some thinking around considerations of green software. The other one I think is quite a powerful thing to do, and it's how I started at Microsoft, and that is start a community to start to think about it. Just talk about it. Think about what you want to do, which direction you want to go in. Just start a community. And the resources in Green Software Foundation are a brilliant resource to go look at, of stuff to talk about. That really does make a difference. Lots of companies now have assessment tools. They use proxies, admittedly, but at least they do give you some insight into where you currently are. In my world, in Azure, we've seen it already. There's the sustainability dashboard, now called the emissions dashboard. So go run those tools. Again, something we've touched on already, particularly around energy proportionality, again, in my world, the Azure Advisor helps you do stuff like this. Go look at idle resources and over-provisioned resources and do something about it. You'll reduce carbon emissions by doing that. And then finally and this was perhaps one of the most tentative linked ones, but it was around .NET 6, and .NET 6 was massive performance improvements, as I'm sure you guys know. And if you use performance as a proxy for carbon emissions, which is a fair proxy to use, that if you upgrade as and when these upgrades become available, the likelihood is that you put yourself in a better position as far as sustainability is concerned. And that's it from me. Thank you for your time. Thank you.